Welcome, folks, and I am honored to be here with you, learning from you and with you. And we're going to cover mapping and cartography, our lecture 1 for our course. And this is the course description as it has been decided upon by the college. And it tells us that this course will cover fundamentals of map use, interpretation, map design, and map production using GIS and geospatial technology. So that's going to be the primary focus of your exercises. You will have readings to do related to all of those topics. The college also wants you to gain experience in the application of map-based analysis in the fields of environment and natural resource management. So that's what we are going to focus on in these recorded lectures. The college lists this as 3 credits, 2 of lecture and 1 of lab, but that is not indicative of how much time you will spend in each. So you won't spend 66% of your time in lecture and 1% in lab because this is a mapping and cartography course. Lab does take a lot of reading and a lot of content that I think of as lecture material, and it also includes a lot of hands-on material. So we will do a lot of hours in lab, but we do need to get some background in order for us to appreciate what we're learning in lab and to think about the concepts of what we are viewing with our geospatial products. And so this lecture is going to cover material in your assigned textbook, and the assigned textbook is called Sustainability, a Comprehensive Foundation. You will be happy to know that this is a free open education resource. I do this for several reasons. One of the reasons is that college is very expensive and science books in general are very expensive. If this area of sustainability is not a primary focus on your career path, it can be very costly to invest in a hardcover textbook or even an online version. So I prefer to use open education resources wherever I can. And the other reason is that open education resources tend to be updated more frequently than your hardcover, and changes can be made in the middle of the semester if they need to be. So this resource is available to you. The link is provided on Canvas. You can read it online or you can download a PDF version. So the overview for this lecture, I'm going to cover what are natural resources, look at types of resources, the link between population growth and the use of world resources. We're going to think about the concept of what is sustainable development. What does that mean? How can we achieve it? And principles of a sustainable society. Okay. A definition of a natural resource is that it's anything that we extract from the biosphere or the physical landscape with the intention to accommodate the needs of man. That's a definition. We can classify resources into 2 primary types, renewable and non-renewable. So some examples that you are probably familiar with are renewable resources would be solar energy, wind energy, tidal energy, which is the movement of water along our coastlines, and biomass, which is the burning of fuels that are biological in nature, not necessarily geochemical in nature. So the differentiation there is if you go to the gas station and you use petroleum, that is a geochemical resource. It's not really considered to be renewable. But if you use gasoline, or if you use, I should say fuel, not gasoline, if you use fuel made from corn, that is considered to be a renewable resource. I do have a vehicle that is runs on renewable resource fuel. I've been very happy with it. The fuel is cheaper and it runs on ethanol, or here in California, it's called E85 gasoline. And my gas bill has gone down. I do sacrifice a little bit in performance. It's a little bit slower, my vehicle is, and I'm okay with that. And I like feeling a little bit better at the gas pumps than it used to. And then our non-renewable resources If you do have a standard vehicle, you are familiar with gasoline and other types of fossil fuels, such as oil and natural gas and coal, are all non-renewable. So the use of these resources combined with our activities results in products, and it also results in a lot of waste. The primary types of resources that I want to cover are forest resources, water resources, mineral energy, land, and food. Please keep in mind we're not going to do a deep dive here. It is intended to give you an introductory or cursory background so you're familiar with some of the concepts, certainly some of the vocabulary, and that when you're looking at a map, let's say, of forest resources, you have just enough scientific background for you to be able to interpret the data and the main message of the map. So forest is defined as an area with a high density of trees. It can be together with other plants, and it covers a large area of land. They are home to 50 to 90% of Earth's species. And forests produce not only material goods, but they also provide several environmental services which are essential for life. There's productive functions. So we all use timber. Most of us use bamboo. Some of us use essential oils. All of those come from forests, as well as many of our medicines, things like latex and various other consumer products. Forests have a protective function. They will conserve soil and water. Erosion and mudslides happen when there's not enough plant cover on a slope. And they also regulate water. If you're interested in the correlation between water and resources, I would highly recommend you read about a woman called Wangari Maathai. She was a Kenyan woman who planted trees, and she reestablished ecosystems in Kenya. She won a Nobel Peace Prize for her environmental work. She was also ostracized within her own country, attacked, threatened for murder was threatened on her life. She was dismissed from her university position. She was very, very controversial, very powerful and influential, and all she started doing in her Greenbelt movement was planting trees to bring back water to barren lands in Kenya. So other protective functions, forests will protect against wind, cold, radiation, and noise. So plants will process a lot of environmental factors, and they are very beneficial for protecting other habitats. There are regulative functions, the absorption, storage, and release of gases, water, minerals, and radiant energy. So forests have been described as the lungs of the earth. And when we think about something like carbon dioxide levels and the relation of that to climate change, there is a cyclical seasonal variation in CO2, and that is primarily because forests are more active in the northern hemisphere in the spring. There's more land cover in the northern hemisphere in the spring. And so when we think about forests as the lungs of the earth, it's like the earth takes a big, deep, deep breath in the spring and breathes in a lot of the CO2 and processes it. And when the northern hemisphere is less active in the winter months, that's when the CO2 from primarily human activities builds up. Okay, so if we look at some direct benefits for resources, I'm sorry about that. We have timber for buildings and furniture. Natural habitats are essential for our flora and fauna to thrive. We also rely on, going down to the right here, we rely on forests for beauty and tourism. There's a very popular movement called forest bathing, and it has initiated in China. And there's a lot of medical research now on the restorative benefits and the therapeutic benefits of just being in a forest. We rely on forests for wood fuel, and we can also get manure from forests, and then raw materials for industries. Building homes and building furniture are primary uses of forest resources. Okay, moving on to water resources. We're all familiar with it. It's the primary ingredient necessary for life. It's the key ingredient necessary for life. And so water resources are useful or potentially useful to humans. Also, it is one of the things that makes life possible on our planet. The human use of water can be divided up into agricultural needs, industrial needs, household needs, recreational, and environmental. And all of these require fresh and clean water. If we look at the distribution of Earth's water resources, over 97% is saltwater. That's our oceans and some saltwater seas and saltwater lakes. About 2.5% is freshwater. This is considering all of the water on Earth. Of that 2.5%, almost 70% of fresh water is in our glaciers and permanent snow cover. 30% is in groundwater, including soil moisture, swamp water, and permafrost, which is permanently frozen areas of soil. And only 0.3% are in lakes and river storage. And so man tends to be very egocentric. We think of the world naturally, how we experience it. And all of the water that you probably imagine when you first think of a water resource is only 0.3% of all of that water available on our planet. So with water use, 70% of the total consumption of man's water use is for agriculture. And when man shifted from being nomadic hunter-gatherers into farmers, the use of the world's water naturally increased. 1% of water use is domestic and municipal, and 29% for industries. I'm going to back up here for a moment. Bear with me. What I do want you to notice is that these graphs are showing you water usage in different countries, and the lines in the graph correspond to the withdrawal and consumption per country. And so the most populated countries, Asia is one of them, but also Africa do not necessarily use the most water. And if you notice here, Asia does use a great deal of water withdrawal and consumption. Places like South America and South America and Africa, while they have very strong and large areas of agriculture, they rely on natural patterns of agriculture much more so than the United States. So the United States, as one of the world leading powers, has an economically driven society, which means that we will often create businesses and we will place agricultural endeavors in places that aren't necessarily going to be sustained by natural forces. In fact, most of the time they're not. And that means that we have to provide fertilizer and we have to provide water coming into the area or withdraw water that's going through an area. That's becoming an increasingly urgent problem as world's fresh water becomes a limited resource. And think about where we live. So, for example, if you think about the city of Las Vegas, even without looking at maps or charts or data, you can imagine all of that water to sustain the people there has to come and be brought in from elsewhere. Okay. And then the other, this kind of a map is showing you data expressed as a third dimension, and rather than just using color or symbology on the map of the countries itself, you can appreciate very quickly that this information in this graph is displayed on this map, and it's showing you the relative values, a very powerful message for comparing quantities without looking at the actual qualitative numbers. And then the scale over here corresponds to these bars that you see in the various colors, and you could then get an estimate of cubic kilometers per year. But visually, very quickly to look at, it's really easy to see patterns and to interpret large data sets. Okay, mineral resources. Starting down on the left, there's two main types, metallic and non-metallic. And minerals are defined as naturally occurring inorganic crystalline solids, and they have a definite chemical composition and characteristic physical properties. They are exhaustible and non-renewable. In general, most minerals are relatively plentiful. Some minerals are overused by industries, especially with the burgeoning and exploding electronic industry of the last 2 decades. The disposal of minerals can have a negative effect on the environment because man goes through an extraction process and concentrates these minerals, so natural systems can't always handle the large dumping or disposal of these minerals, which in great quantities can be toxic to life around them. Our main uses of minerals, we use them in industrial plants and machinery. We can use them for generation of energy in the production of coal, lignite, or uranium, are some examples. Minerals are used for construction and housing and settlements, so all of our electronics, a lot of our features that we build with rely on minerals. They're used for defense equipment and weapons and armaments, and finally for transportation means. Next type of resource I want you to think about is energy, and the substances from which we produce energy are known as our energy sources. We all need energy for our day-to-day life, and two main categories, renewable and non-renewable. So with renewable energy, we are extracting energy through technology that's making use of something that is relatively unlimited. So solar energy for human purposes is considered to be unlimited. We cannot overharvest sun's energy, I should say. Hydropower energy, it's not steady. Not as much as the solar energy in a lot of parts of the world, but in some parts of the world, hydropower can be as consistent and as powerful and plentiful as solar energy. We also have geothermal energy. So if you've ever experienced hot springs, you understand or appreciate that there is a lot of geothermal energy that comes from beneath the Earth's surface. We have wind energy, and wind farms are very popular. They're considered to be a clean technology, not without problems. There are issues primarily with wildlife and conflicts with the large structures